Hello everyone, my name is Yu, and I'm in Group 2, so today I will have a final project in the Geostatistics subject. So I have divided my presentation into four main parts. The first one I will review a little bit about the paper review of SBE. The second one I will give you some theory about the grading. The third one I will have a test data and evaluation. And finally I will have a conclusion for this. So let's turn to the first part, paper review. The paper review of SBE 190051MS. This paper presents a methodology for geostatistical estimation of reservoir properties to handle the uncertainties in observation and modeling, given certain known data in geological region. The grading methodology used to estimate or predict spatial phenomena at non-sample locations from the estimated random function. The approach assumes that the data is accurate and precise, and the random function is generated from a true descriptive analysis for known datasets. Regarding the assumptions considered in the classic grading, it is realistic to assume that spatial data contains a certain amount of imprecision, mostly due to measurement errors and the information of lacking to properly assess a unique random function model. So now let's turn to a theory. So in this part, I will give you a definition about the grading and two main parts, the simple grading and ordinary grading. Among all estimation methods, grading is one of the most commonly used algorithms. Most reservoirs are heterogeneous and present unique variation of continuity due to their specific depositional structure and their genetic history. Given this challenge, grading can find a solution that honors data and spatial relationship between the data and the unknown, as well as the grading data points throughout the diagram. So the simple grading is mathematically the simplest but the least general. It assumes the expectation of the random field to be known and relies on the covariant function. However, in more applications, neither the expectation nor the covariation for behavior are known beforehand. The practical assumptions for application of simple grading, they have three main parts. One says stationary of the field or variant stationary. The expectation is zero at everywhere. Known the variant function. So the ordinary grading is the most widely used grading method. It serves to estimate the value at the point of the region for which diagram is known using the data neighborhood of estimation location. Ordinary grading also can be used to estimate a block value with local second order stationary. Ordinary grading implicitly evaluates the mean in the moving neighborhood. To see it, first grading estimates the local mean is set up. Then, a simple grading is estimated using the graded mean is examined. So now I will move on the test data and my evaluation about the data. So the first is the given data. So in here you have a given data, four variables. The first one is a location, x coordinate. The second one is the y coordinate. The third one is the column of z, which is called porosity, and the z2 here is permeability. So After inputting the data, the diagram of porosity will be calculated. As the figure with the spherical method, the nugget variance is nearly 0.00063A and the seal is 0.00128 and the range of this is 3331. But in Gaussian, the variance is quite higher and seal is also the same. Furthermore, the R square in the spherical is higher. It means that the data is more trusted in accuracy. So the suggestion model for this data is spherical model. Also, the same with variety, the suggestion model is exponential. In this model, the proportion is substitutable and also residual is more accurate. As you can see here, in the exponential model, the nugget is over than 2000 and the seals is over than 4298 with the range is 100328. So this data is better than two method, Gaussian and spherical. So in here you have the figure of the creaking. So I can be seen here. In this one is about the porosity. So you can see that the creaking in the left hand side you have the symbol creaking, and the right hand side you have the ordinary creaking. So as you can see that the symbol creaking is the most symbolist in this figure. It shows that the range in permeability. But in the ordinary creaking, you can see that it has a little bit change with the porosity is changed with the white color. It has more than the left hand side, and it also have the same meaning with the theory that the ordinary will give you the data and the value is more accurate and is more specific than the symbol one. Also, in this presentation, I also calculate the correcting. So the correcting here will give you the data more accurate, more trusted than the creaking. So on the left hand side, you have a symbol creaking, and in the right hand side, you have the ordinary creaking. So as you can see that in the left hand side, the yellow color is much than the right hand side. But in the right hand side, you can see that the data is more specific, more accurate, and you can trust the data in the ordinary of the core creaking than the left hand side. And they replay in omit some data to make the value will be more accurate. So now I will move on the cross-validation creaking. So the regression coefficient at the bottom of the graph represents a measure of the goodness of fit for the least squares model describing the linear regression equation. The standard error SE here refer to the standard error of the regression coefficient, and the R-square value is the proportion of variance explained by the best fit line. And the y-intercept of the best fit line is also provided. The SE here, the standard error here prediction term is defined as the SD multiplied with 1 minus R squared and all of them multiplied with 0.5, where the SD is standard deviation of the actual data and the data in the data graph on the y-axis. So as you can see here, so you have the regression coefficient is nearly 0.97, with the SE, the standard deviation is nearly 0.119, and the R square is nearly to 0.251. The graph here is isotropic diagram. So now we move on the conclusion. In conclusion, you can conclude that the ordinary clicking is better than the simple clicking. I already told with the figure before that when you have the comparison between ordinary clicking and the simple clicking, so the ordinary clicking gives you the data and the figure is more specific and it's more accurate, it's more detailed than the simple one. And most the common also the ordinary clicking is commonly used in this field. Also, clicking gives the best result than clicking. So in clicking, the porosity, the variability, some value about the Z or Z2, it will be given more specific, more accurate, and you have a comparison between clicking and the clicking. You show that the clicking they give you the data is they give the data more accurate than the first one. So here is references I use in the presentation. Thank you for listening.